Hello, my name is Bryan Smith. I'm the Technical Director for Databricks Retail and CPG Industry Team. Today I'd like to talk to you about taking a look at customer churn. Whenever we do any analysis on the customer, I always like to start with a reminder that not every customer is created equal in terms of their profitability. Some customers have high profit potential for us, and those are the customers that we want to identify and retain over the long term for the health of our business. Other customers have lower profitable potential, and while in some other demonstrations we'll talk about customer lifetime value, here we simply want to recognize that there is a difference between these, and that's always a part of what informs our analysis on the customer. Now that said, when we do identify a good customer, this is a customer we want to retain. The longer they stay with us, the more value we get. That part's pretty obvious and pretty clear. But also, customers who stick around for a while tend to be more happy or satisfied customers, and these tend to promote our services to friends and other family and peers, and that helps us acquire more high-value customers in the process. In addition, when we think about customer retention, we always want to keep in mind that retention is significantly cheaper than acquisition. Identifying new customers, marketing, promoting, and getting one to kind of get over the threshold of come into the store for the first time or sign up for the service for the first time is quite expensive. And whenever a new customer arrives to us through those mechanisms, we're never really sure of what we're going to get. Is this going to be a high value customer for us, or is this going to be a lower value customer for us? Honestly, that's something that's very difficult to tell until we've had a little time to build a relationship. So with that in mind, we want to put a lot of energy into retaining those good customers that are already with our organization. Now, there are two ways that we typically think about this. One is more customer specific, while the other one is a little more population specific. In the customer specific churn prediction, we're trying to identify which customers are at risk of abandoning their relationship with us over usually a short-term period, typically 30 days, 60 days, 90 days, depending on our business model. If we can identify that a customer is likely to churn, that's a customer that we can proactively engage and attempt to keep them with our services. At a population level, we like to look at the probabilities of abandonment and how they transition over time. This will help us understand the high-level factors that create pressures on our customers to leave, and whether that's to leave the service outright or go to a competitor for the needs that would otherwise get resolved through us. This is the focus of our survival analysis technique. The common analogy that we use to kind of explain these two type of techniques and how they relate to retention management is that if we think about customers leaving our organization as water falling out of the bottom of a leaky bucket, we certainly want to scoop up the water that's fallen out and put it back in. And that's our churn prediction, churn management activities. But we need to get ahead of all the water coming out of the bucket and really work to patch the holes that are there. And that's very much the focus of our survival analysis. So with that in mind, I'd like to take a look at these two techniques, walking you through a fairly detailed demonstration of the two. But to do that, before I do that, I want to introduce you to a data set that we're going to use from this. Back in 2018, KKBox, a web-based streaming music service out of Taiwan, released a data set and asked the data science community to assist them in predicting churn. There's quite a bit of information inside this data set, but the core assets that we're interested in are the member profile data. We're also interested in account transactions. Those are the transactions that change expiration dates, change payment procedures, and the like. And then finally, the user log information, which helps us track the user engagement of the services over the lifetime of the subscription. You can download this data set at the link that you see on your screen. And if you'd like to do that to work on some of these techniques, whether that's to use the assets we're about to demonstrate or to do other work on your own, please take some time to read the terms and conditions under that data. And with that, let me flip over to our churn analysis. So here we have the data that we just discussed, and we've got to do quite a bit of data preparation work. The data comes in as a collection of files that we can then map to these tables that we described before, and there's a lot of data manipulation, massaging that we have to do to get it into the right format. I'm going to scroll down here a little bit to where we kind of get closer to what we call the final result in this. But I do want to acknowledge that some of the complexity and the messiness that you're going to see here is not uncommon. This is actually fairly typical of what we see with most of our customer accounts. But our goal, regardless of the messiness, is to get it structured into this format. What we'd like to do is understand for each customer that we believe to be at risk of churning within a certain period, we'd like to go ahead and flag them as to whether they churned or not. So this data set goes till the end of March 2017. What we're going to do is we'll build a training set where we evaluate whether a customer churned in February of 2017. These flags tell us something about the churn status, with 0 being they did not churn, and occasionally you'll see a 1 in here. It takes a little while to find, but you will find 1 in here that indicate that the customer did leave in February. We're going to use that information to train our model. To test our model, we're going to build a very similar set, and the logic for that exists down here. We kind of scroll through, it's the same stuff as above. But what we're going to do is we're going to calculate which customers churned and which ones did not churn for the period of March. So we use our training set to train our models and our testing set to evaluate their accuracy for a period that those models would not have known about going into the training exercise. All right, now we get into our feature engineering. And there's a lot that we want to consider. We want to take information from our transaction log. We want to take a look at changes to the accounts that might have occurred since its inception, changes in the accounts that might have occurred in the last 30 days leading up to the period that's at risk, and so on and so on. We also want to come through here and analyze information related to activity. Again, are you using the service more in the beginning, less towards the end? Is it fairly steady? What kind of shifts and patterns can we see that might tell us something about whether or not you're likely to churn? There's a lot of code in here that basically builds up a bunch of features that we're going to use. I believe on this one we counted over 100 features. What's very typical in a churn analysis is we often are sorting through hundreds of features that we might generate from this kind of data. But let's go on to the real crux of the problem that we have here. So you saw earlier when I pulled up my churn scores that we didn't see a lot of 1s or really any 1s in a bit of a scroll. And here's why. What's typical in a churn analysis is that if your business is relatively healthy, the number of customers that are likely to churn inside of a given period is fairly low. Here what we can see is that for our training period, which would be February of 2017, only 3% of the at-risk customers actually left the service. And then in March, which represents our test period, only 4% left. These percentages are actually quite good for a subscription service. I think a lot of people in this space are envious of these kind of scores, though obviously KKBox wants to get these numbers down even lower. But for us as data scientists, the fundamental problem we have here is that our model can actually make really good high accuracy predictions just by assuming that nobody was going to leave. So here, for example, if I create a naive model and I say that nobody leaves in our training period and therefore nobody leaves in our test period, that'll give me over a 96% accuracy. And clearly we're missing the mark here. We're trying to identify who is susceptible, even though it's going to be a very low number of people, to actually leaving. And this requires us to push beyond all of these zeros, the non-churners that are inside of here, to really get at this small subpopulation of people who actively churned. So there are a lot of techniques that are promoted for doing this. And inside this notebook, we actually spent quite a bit of time going through those. A lot of folks like to take a look at confusion matrices and build what are called ROC curves to give you a sense of how your model behaves. That said, when our data is imbalanced like this, where there's a small population of folks that are in the positive class, in this case churning, this gives you an inaccurate, misleading representation of the value of your model. So we spent a little time talking about the use of precision and recall as alternative measures. Precision tells us something about how confident we can be in our predictions. When I say that someone's going to churn, are they really going to churn? So it's kind of a measure, you could almost say a degree of accuracy. Now recall is a little bit different. Recall asks, how many of those are churning am I capturing when I set my threshold for predicting churn at different levels? So in other words, how complete are my predictions? We can plot these against each other using a precision recall curve, as you see over here. to look at how the two interplay with one another. As I set certain thresholds higher, I have to have more evidence to make a prediction that someone's going to churn, and that affects my precision. But as I set my threshold higher, I'm also going to miss a lot of folks where I had lower levels of evidence that they were going to churn, but they did churn. And so this examines the relationship between the two. Understanding these things visually is really important, but we need to get this condensed down to a singular metric. Area under the curve is sometimes used for capturing the area under the precision recall curve, but it too suffers from some problems when we deal with these imbalanced scenarios. And so we arrive at an alternative measure called the average precision score, which as it goes from 0 to 1 and increases along that range, we have a better prediction of the positive class, balancing precision and recall. So that'll be the metric that we use. There's quite a bit of explanation of it that's in here. It's worth reading. And then we'll go through some other techniques. To deal with this imbalance problem, there's all kinds of things that we want to do with giving the positive classes higher consideration, and we can see the impact here. These green curves represent our precision and recall curves from above. And then the orange curves that are on here represent the effect of giving the positive class higher weights that are on par with the negative class. You can see some of the adjustments that take place there. We also want to examine how different algorithms have an impact here. We started off with probably the most traditional algorithm that's used for this called logistic regression, but we also evaluate random forests and gradient boosted decision trees, neural networks, and so on and so on. What we find is that with different data sets, different models actually tend to have better predictive capability. And so there's no one-size-fits-all solution to this. So we really want to try a bunch of these to see what's working best for us. The last thing we want to try here, though, is an ensemble. So it turns out that when we're doing predictions, some models are a little bit better at capturing some subclass of our churners than others. And so what we can do with an ensemble is we can actually take multiple models and find ways to aggregate their predictions to form a single prediction that's a combination of two or more of these models. When we do this, what we find is that often our scores, our predictive scores, are higher than any of the individual models on their own. So this is a great technique to use to just get a little bit more predictive capability out of your solution. With that in mind, now that we've kind of decided on how we're going to measure our churn predictors, we're going to deal with some of the weighting around the imbalance and the different type of models that we want to use, we then go through and start training our models. On this first one, we're taking a pass at XGBoost. So each of our models has hyperparameters, and some of these actually have pretty severe consequences for the predictive capability of your model. So here we can see some of the parameters that we feel we may want to use in a scenario and the range of potential values that we need to explore. This is often done in a hyperparameter tuning exercise where we run through different variations to find which combination of values give us the best score. Using a capability called HyperOp, what we can do is we can automate this and distribute this work across a Spark cluster. In doing this, what we're doing is we're running multiple models in parallel, we're learning which combination of parameter values tend to give us the best results, and then we're using an algorithm inside of HyperOp to then make further adjustments to those, learning from what worked and what didn't, to then kind of move us in a different direction and arrive at an optimal. As you scan these results, and this one we ran 250 times, you will see that our score goes lower and lower here. The idea is trying to minimize something. So this actually is our average precision, which improves as we increase. So we simply multiplied it by -1. This is explained in the code to arrive at a good result. And you can see where we land here towards the bottom with our final combination of parameters. Now, these are the final ones we arrived at. These are not ones that we likely would have just guessed on our own. So really iterating through there to find these was the best path forward for us. Using this technology in combination with Databricks and MLflow, there are actually some really neat visualizations that can help you understand how different parameter settings interact with one another, so that when you then go into future runs with this data and this algorithm, you can better constrain that search space that we just navigated. We do this for all of our models inside of here and arrive at a final result. And then in the last notebook that's part of this, we then focus quite a bit on making this ready for release into production. So one thing we always want to think about when we're trying to predict churn is we are trying to create scores that we can then put into the hands of the people responsible for retention management. So in this notebook, we actually take some time to generate output that can then be absorbed into a CRM system, which is typically used for this, something like Microsoft Dynamics or Salesforce CRM solution or the like. So we're taking this end to end with our data set after we've made our predictions. Closely related to this, we spent some time over here talking about survival analysis, and I'll just jump into the notebooks on these. It's the exact same data set we're doing here. The key difference is we're trying to organize this same data a little bit differently so we can understand how customers drop out. I'll jump over to the next notebook in the series so you can see what this looks like. But this is how we're trying to structure our data. So here we have our customer information. We know when their subscription started and when it ended. Now, not every subscription by the end of this data set has petered out. And so for those, we have an end date of unknown. But between these, we can calculate the number of days that we've had this customer under observation. This first customer, for example, started their subscription on September the 9th and terminated on the 14th. And we calculated 6 days of engagement of the service as part of that. Here we have a customer that started on November 21st of 2015 and ran all the way through to the end of the data set. So at the end of the data set, we had observed this customer for 498 days. Now the key difference between these two is that the first one we actually did see leave the service, and so we'll flag it with a 1 to indicate that it churned. But the other one we did not. We refer to this as a right-censored individual, so we'll flag it with a 0. Of all the data you're seeing here, the main thing we need is some sort of unique identifier for the customer or the subscription, these duration days, and these churn flags. With that information, what we can do is we can generate curves like these that tell us something about how people leave the service over time. So on the y-axis, you're seeing our survival rate. This is more or less the percentage of the population that sticks around to a certain point in time, that being days we're seeing here across the x-axis. And what we're seeing is overall, there's a fairly steep drop right at the beginning and another steep drop leading right into the 30-day mark. After that, customer decline is kind of a staircase type drop-off that occurs in small waves, more or less coinciding with the 30-day renewal period that most customers enter into, and then kind of a long tapering decline that we see here until there's another drop a little bit past the 1-year mark before it hits another plateau. This graphic tells us a really interesting story about drop-off inside of our customer population. But where it gets really more interesting is when we take the time to break it down by different factors. So for example, here we're taking a look at customer registration for the service through various channels. Some channels, like this golden one you're seeing down here on the bottom, channel 4, are incredibly loose. Customers come and rapidly leave. Other channels, like the green one here, channel 7, are incredibly sticky. Customers come in and they stick around. There's a huge gap in terms of retention between the two. This is a place where we'd want to take this analysis and, of course, test for its statistical significance, which we do down here in the code below, but use that information to have a conversation with our marketing department about why it is that some channels tend to be stickier than others and how we might want to consider investing or not investing in some where customers don't seem to stick around for a very long time. We might also take a look at other factors. Here we take a look at payment methods. Now, what you're going to notice here is this is a much busier chart because we support a much wider range of payment methods, but some have radically different outcomes than others. Payment method 35, for example, shows a really high drop-off suddenly, and then people there's a low retention rate after that. This might be, we don't have the details of exactly what these are, but if we had to guess, this is probably someone receiving a free voucher for a 7 or a 10-day trial and then failing to renew. If I was to take that into marketing, that would be money that we don't want to waste on customers. Instead, other payment methods that have really high retention rates are ones we probably want to incentivize more people to kind of move into those channels. We can take a look at various factors that we would have information for at the beginning of our service and arrive at a variety of these things that would inform us about the health of our business. We can take this too into a little bit more of a sophisticated exercise where we take that same data and we actually look at the multiplicative factor of each of those elements in combination with each other to understand how it affects customer drop-off. So inside of what you're seeing here, there's a baseline model that describes how customers leave the site over time. But when this occurs, or when a customer comes in combination with, say, payment method 20, we can see that there's more than a 5 times multiplier to the risk that this customer is going to churn. Right? Likewise, when we see things like this, payment method 34, that tells us that it cuts their risk of churn in half. So there's a lot of really interesting interpretive value we can get from these. And of course, these things do occur in combination, so simply we multiply these by one another to get the aggregate effect of different combinations of payment methods and payment channels. Now, there are other factors that we need to consider in here, some of which have time-dependent components of their own. And so there are certain ways that we can model those. But using this information, we can start to arrive at a much more detailed understanding of why it is that customers leave and start to use that to take corrective action on our business model. Now, that was a really quick pass over of some notebooks that we have around churn prediction and customer survivorship. I've put the link out here so that if you want to download those, please read the blog, but grab the notebooks at the bottom and you can use it in combination with the data set that we described to repeat the work inside your environment. Closely related to this is the concept of customer lifetime value. And that one, we've also put together detailed notebooks talking about how to calculate that in non-subscription models. And you can take what you learned there in combination with survivorship and do it inside of subscription models. And then while we didn't discuss it, I want to let you know that we also have some content related to customer segmentation that'll be coming soon. And that's something you also want to take into consideration as you're examining customer retention. So with that, let's say thank you for your time today. Hope you're having a great summit and look forward to your responses. Thank you.